Now let's first start with electronics, semiconductors, and the AI revolution. Now, as AI adoption accelerates, the spotlight is often on software and the algorithms. However, every AI application relies on powerful hardware, from semiconductor chips to processors to sensor, communication system, and edge devices. Now, with India's semiconductor mission, chief manufacturing initiative, and increasing investments in electronics manufacturing, demand for hardware talent is expected to rise significantly alongside software expertise. So, my first question to Professor Nondi: as AI applications depend heavily on hardware infrastructure, are we entering an era where electronics and semiconductor expertise become as important as software skills? Over to you, sir.
Okay. So it's a very good question. And I can say, yes, in fact, artificial intelligence actually does not exist in isolation. And you can see that whenever the AI is actually familiarizing within the normal people or for the students, they initially thought about as a software revolution, a big software revolution. But ultimately, as the AI is progressed in its way, and we are entering into a smart communication or artificial intelligent network designing, then you can say that not AI is not dependent only on the software algorithms, but it needs the backbone, where the backbone remains in the hardware,
Right.
where the hardware needs the basic thing that is called the processor. Actually, AI is doing with a large amount of data. So
Excellent.
who will process the data? So that is the processor. So whenever we are dealing with the processors, we are actually entering in the electronics era. So
Mhm.
that means the semiconductor devices. And you can see in today's world, the big semiconductor companies like NVIDIA or Intel, etc., are investing billions of dollars to design the new AI adaptable processors,
Correct.
which cannot be done with our normal CPU that we are using today at home. And we need a different processor like GPU or TPU, etc.
Mhm.
So they are actually moving or shifting their focus to design a more adaptable processor, more fast processor. And because the thing is that whenever AI is becoming larger, certain points are there, certain limiting factors are there. First of all, obviously, that is the software algorithm. But along with that, in the hardware perspective, we have several limits like efficiency of the system, the speed of the system, and obviously the energy consumption. Because we are in today's world, we are moving towards a green energy.
Right.
Right. So in that sense, AI and AI software and hardware is going together. They are not isolated. And
Correct.
we cannot isolate in our modern era. We cannot isolate which is software, which is hardware. The border is actually uh,
Blurred. Yeah.
blurred out. Okay. So in the same sense, India also started the semiconductor mission to design the chips, design the semiconductor manufacturing companies, or to find out the semiconductor manufacturing companies, so that India can itself generate a good, its own AI infrastructure.
Correct.
So we can say that future belongs to hardware software co-design actually.
Right. So they should be going
So
hand in hand, right? So,
hand in
ah,
hand,
right.
obviously. So, for example, suppose today's AI engineers actually developing an efficient neural network.
Correct.
So, this neural network also needs, that is needs hardware, software algorithm also needs some hardware. Okay. So, similarly, the VLSI designers who are earlier completely focused on designing some chips or hardware parts, they are also designing some accelerators which will act for this neural network.
Mm-hmm.
Okay, so they are actually bridging up this hardware software part. Okay. So in that sense, we can say that a AI model can consume a huge amount of energy, and that we can save by designing some energy efficient networks also. Okay, so in brief, we can say that AI revolution is not just a software revolution, but it is equally a semiconductor revolution that is bridging up the hardware software domain.
Okay.
So I think this will give you the idea how the today's modern world AI can be. AI also actually needs some expertise from the electronics area also.
Absolutely, absolutely. Now, thanks for briefing on that part. Yeah, of course. Like, and most importantly, if I remember correctly, when we did our study in the electronics, right, radio physics electronics, that time also AI is there. It's not nothing new. It's just right getting democratized. It is reaching to the mass now, right? Now there are again various reasons behind that, but ultimately the truth is, right, AI can only work when the infrastructure is present. Unless and until the infrastructure is present, right, AI can also be can also like right, it could be an overhead also. So semiconductor, these things, the basic electronics, right, the need of the basic data is not going to go away, right? As you rightly pointed out, sir, these should go hand in hand. Now let's move from the basic electronics or electronics communication to little, right, quantum technologies, etc. So